So what is a hole? Well, a hole is the open circle that you can see right here. Now, it's just another way to represent that something is undefined, okay? So now, so on this graph right here, we have two features here. We have the vertical asymptote, and we have the hole right here. They both represent something is being undefined, okay? They are both representing something, some x values are being undefined. But how do we know when it's going to be a vertical asymptote and when it's going to be a hole? Now, this is the process you really want to, follow closely so that you understand the thought process. Now, let's look at this example right here. Okay. Minus 7x plus 28. Okay. Over x squared minus x minus 12. Could you go ahead and factor the numerator and the denominator? Could you go ahead, factor the numerator and the denominator? So if you factor the numerator out, you would have negative 7 on the outside, and inside the parentheses would be x plus or minus? Minus 4, okay? In the denominator, all right, you would factor this into x minus 4 and x plus 3. Now, before we go any further, let me just quickly ask you something. Can you tell me the restrictions? What can't x be? Oh, wonderful, wonderful, wonderful. Now, and then can you see something special right here with the factored form? We can cross out x minus 4, right? So again, let's go ahead and cross it out. And so therefore, we reduce it to just negative 7 over x plus 3. Now, let me ask you this question. If you look at this, all right? If you just look at this, is it okay for x to be 4? Because? It doesn't make it undefined, right? But then if you look at this, before we cancel it out, could x be 4? We say no, right? But this came from here. So even though we simplify it and the x minus 4 is no longer there, but we still hold the restrictions true. So x still cannot equal to 4. So how do we know we will have a hole? Whenever we cross out a term. Whenever we cross out a term, then we will have a hole. And so how do we find out where the hole is? We'll say, well, so we're going to graph this. Okay, now this is how I'm going to phrase it. We will graph this as normal, but, okay, with a but, huge but x still cannot equal to 4 due to the restriction. But how do we know where the hole is? The hole is at where? We simply put in the 4 into x. Because we'll graph this as normal, we will artificially, we need to manually place an open circle there. So we say, oh yeah, it's negative 7 over 7, which is negative 1. And that's the reason why at 4 comma negative 1, we have a hole. Okay, so the concept is very simple. We said, oh yeah, we have restrictions. Oh, and then somehow the factors got canceled out, but that shouldn't, we shouldn't ignore the fact that x still cannot be 4. So that's why we have a hole, okay? So whenever we cancel something out, that's when we will see a hole.